Ah, oh, don't mind me. I'm just getting a little bit hyped. Why? Because I'm going to claim we're finding the fine structure constant through the Planck charge boundary. People have totally done this before. I haven't heard as much about it recently. Well, you all know what that means. We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyperrulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, we're back. So apparently, I kind of had the feeling. I have no idea if this feeling is true. I'm sure you could probably kludge whatever you want, but there should be other ways that you can get at different constants in nature, because this is these things we keep on finding, and it's like, oh well, it's like you can do this, you can do this, you use speed of light a bunch of times over big G, and then you get like Planck force or Planck power or something like that, and we're not using H bar and stuff. It's like, all right, that's cool. Why do these things line up? Why is it if you take the Planck constants and you plug them into the dimensional ingredients for all these things, you either get that particular constant or you get it pretty dang close. I'm just saying, I took a look and I saw a familiar friend. And when I saw that familiar friend, I got to thinking. So I checked a little bit. And I did a quick cursory search, and I didn't really find much stuff on this. Here's the thing that you see. Let's just go to our friend the Planck units there. Again, stuff's in the doobly-doo. Feel free to follow along with the computational notebook link there and everything. But where are we? I just don't hear folks talk about this much. It's like, because this is one of the things I found. It's like, all right. And the way they explain it is, compared to stone units, Planck base units are all larger by a factor of the square root of 1 over alpha, or the fine structure constant as we know it. Equals approximately 11.7. Alpha is a fine structure constant. Yada, yada. Oh, let me embiggen this. I apologize. All right. Okay. And of course, they have this Planck charge. All right. Square root of 4 pi times the electric constant times h bar times the speed of light equals approximately yada, yada, yada. And that's a bunch of stuff going into that thing there. Times 10 to the negative 18 coulombs. Yada, yada. Equals approximately 11.7 E. What is E? Well, that's elementary charge there. Technically, could be the charge of the electron, which we classify as negative, or the proton, which we classify as positive. Very interesting how that seems to line up so well. But essentially, let's go back to this. I know I spoiled the surprise. Everybody. It's all right. Hey, awesome one. What's going on, my friend? Yes. We were talking about the physics planks, which, to be fair, if one was planking physically, that's probably a larger plank, depending on which one. But I digress. All right. A little thing. So what did I do? Well, you can just do this on Wolfram Alpha. You type in Planck charge. All right. You hit the enters. You get your full Wolfram Alpha results. What do we got here? All right. You get the Planck charge. Let's embiggen this a bit because I'm blind and wearing sunglasses. All right. So basically, Q sub P, the Planck electric charge. Ooh. The definition. Oh, this is a fancy one. It's got the 2 times the square root of pi for some reason, times the square root of speed of light, the electric constant, and h bar. Yada, yada. Gives us these numbers here. Okay, there. But then I'm looking at these numbers. I've seen these before. And then I see this number here, and I'm like, this number looks kind of familiar. I mean, for those who were paying attention about 90 seconds ago, looks kind of like that number, except we got some more significant digits. It's saying there's something there, and to be fair, I kind of forgot about that for a while. But I looked at that number. The reason why is because let's do one more. Go back to our friend, the hyperbolic Mobius partition function, or the hyperbolic Mobius connection equation. The name is changing to affect its actual description. Where did I put you? Here we go. Okay. And just go to our friend over here. Okay. Because for me, I feel like I don't think it's really that I'm smart really or anything. It's more like I have like a semi-videographic memory. And I see something, if I see it a couple of times, kind of flash. I remember like a little bit. I don't remember it perfectly, but I remember little bits and I can kind of piece them together. So it's like that 11.7 something like, that look pretty familiar. Where have I seen something like that before? And I looked around here and I'm okay, well this okay, never mind. Oh, that's what it was. All right, Joe won. I got confused because oh my god, I lost myself. All right. Because basically the fine structure constant, people like to remember it as more like the inverse of the square. Because what you do is you square something and that'll like doesn't matter if it's negative or positive, you'll end up getting you're basically squaring the amplitude to figure out what your actual range is. Because it could be here, it could be there. So my thing is we very often remember as 1 over 137. Why? My claim, I'm not sure the scientific basis on this, but it might be true, is that 1 over 137 is a lot sexier than, oh my god, it gives us 0. There's a Wolfram Alpha bug. I need to report this. All right. 11.70. Okay. Basically, it gives us this number here. Wow. All right. I need to report this bug. This is just annoying now at this point. Oh, it needs to rationalize. Boom. Plain text. Okay. Basically gives us this number here. Okay. 11.7. I'm like, huh. It took me a while, kind of like this, to figure this out. And then I came out from the other way. So just go back to our notebook. Okay. So we got those. Basically, that's the number of, if we express the Planck charge in terms of the electron, its property of charge, it would be 11.76. Yeah, that much. That was very interesting. So I'm like, all right, go there. 17 times the Rydberg electric charge, not like this tessellation of 17 particles or something like that. All right, let me make this a little bit bigger. All right. Okay, so what I did is I took that number. So I'm like, all right, how do we do this? Oh, pardon. Hey, Charlie. Thank you for joining, my friend. We're just going over some of the interesting coinkydinks of charge and stuff. So, all right, in this, I read the bold claim. Let's go dimensionless. We're talking about Planck charge, and with that, it's like we're comparing similar things. All right, strip the dimensions off, and it's worked before. Assume the magnitude when expressed in quantized charge of our friend the electron. All right. Oh, so it's all right here. So I did the 1 over that. I got this number here. I'm like, number looks a lot like Joe 1 from our friend, the formerly known as the hyperbolic vortex equation, which is how it was part of the convincing evidence that I'm like, maybe I should join the physics monastery. There seem to be answers to a lot of questions that a lot of smart people have. And I'm like, all right. So it gives us that there. Not quite the same, full disclosure. But okay. I look at that. I'm like, huh. Okay. Our friend here looks familiar. Let us square. Go, Wolfram Alpha. So I squared it. This is the number that we got here. Okay. Cool. All right. Oh no, I lost my thing. It's breaking. Hold on. Reload the page. See? It's always the gremlins or cosmic rays playing around. But go back down here. Boom, boom. Okay. So we square it. We get our input interpretation. Okay. I'm like, all right. Well, that's our output right there. All right, let me copy it to our clipboard. What's the fine structure constant? According to Wolfram Alpha, and again, there's, depending on who you ask, you'll get different answers and everything there. It's like, okay. Oh, it's that. Which basically, this is a dimensionless constant because all the other constants cancel each other out. And it's expressed, its definition, according to modern physics, is the charge of the electron squared, all divided by 4 pi times the speed of light times the electric constant times Planck's reduced constant. It's kind of a mouthful. I think that's why alpha is a little easier. Interpretation, electromagnetic coupling. All right. Let's compare the results. This is the fine structure constant that we have right up here. Okay. This is the result when we just did 1 over element, the amount of quantized electron charges in the Planck charge. We got 007, we got 29, 73, 52, 57. And again, some folks say it's like 65 or this or that. Over the years, it's gone up and down. So we want to be open and transparent about that. Let's compare results. I don't know. What does everybody think? I think it's pretty neat. And again, I could have just read that. I'm sure a lot of other people have noticed this and everything, but it's like I just happened because I recognized that number from when I played around with Joe 1 before. I'm like, this looks very similar. Huh. So, and then if we use our Planck charge versus the Wolfram Planck charge, you can say maybe it's more accurate or stuff, or they're saying it's 10 significant digits. It's like, oh my God, here I'm praising Wolfram and then doing a little finger wagging too. Why? Because it's adults and we're trying to do science. What are we supposed to do for science? We're trying to look for truth. We're trying to do useful things for humanity. I don't know. Wise man once said the truth was out there. There may or may not be getting a sequel. I don't know. But it's this the funny thing is, Charlie, apparently myself and some of the folks from the monastery are going to be going down to the first annual DemystifyCon in Austin, Texas in April. I think Thad's going to be giving a talk there. I'm going to present at least a little poster, stuff like that about I dub it eternal cyclic cosmology because I just listened to the model that Thad lays out, and I'm like, okay, you've told me these things. I'm like, all right, we have these other things. I like it because 1, I'm biased. Number 2, I'm biased. Number 3, I couldn't have come up with something so beautiful. And number 4, it kind of gives a physical explanation for a prime mover. But that's a story for another time there. But the third dimension, to be fair, when we're counting awesome ones, sometimes starting with 0 is very useful. It's almost like one may consider 1 the 0th prime. But it's, the amount you learn from waves, this is the thing. We literally have the modern Library of Alexandria at our fingertips. You can learn because, like, literally, I'm a dude on the internet. I am a dude on the internet that somehow, by being extremely blessed in life and extraordinarily curious, I joined a place called the Physics Monastery, and it's looking like there's progress. Couple confirmed experimental results, answers, and working on an ontology for what's going on. Okay, now I'm just bloviating here because it's no. Hey, we all have our own paths in life. Honestly, for a while, had I been born 10 years later, I'd just be on Twitch right now playing World of Warcraft because there was a point in my life where I enjoy playing World of Warcraft. If I could do this for a living, I totally would. Doesn't mean you can't seek outlets, other things, or at least associate with different folks in communities, and you never know. You have fun. Maybe you'll make friends. But all right. This has been my impromptu TED Talk for the past 3.5 minutes. But other than that, hey, personally, I think Wolfram Alpha is a pretty cool tool. It's free. You play around, and who knows? Maybe you'll notice something interesting nobody else has noticed before. Kind of like Euler. Look at polygons. It's like, wait a second. The difference with the vertices, edges, and faces, when you align them a particular way, the difference is always 2. Why? I guess that's just the way our realm works. But peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but I think 2024 is a new door for us. So peace out, everybody. Catch y'all later.